Okay, so here we are with Module 5B Part 2, where we're going to be doing the text mining assignment of the Federalist Papers. This video, I promise, is going to be much shorter than the first video, so now that you've made it through Part 1, congratulations, and here we are on Part 2 of 5B, and it's going to go much quicker. The first thing to do is to download these notes. Now, what we're going to be doing is using that bag of words approach to assess frequency patterns of function words or of so-called stop words, function words, across the Federalist Papers to investigate the likely authorship of the disputed series of Federalist Papers. So we talked about this in a prior video. Here's where we're actually going to do the analysis. So to do this, the good news about this Part B is that it requires very little coding. There is a package that is intended to do much of the work for you in terms of analyzing these patterns of function words without you actually having to do much coding at all, and that's this stylo package. So as of this writing, you will need to install it on your copy of rstudio.gbcu.edu, and we'll go over that in just a minute. So go ahead and download the notes and start reading through those, just the first few pages, and then download the data. Oh, I'm sorry, we're right here. I was pointing the mouse to the wrong section. So download these notes here for the text mining portion of the assignment, and then the data right here. So I'm going to upload that zip file, and let's see. So here we go. So then module, let's see, text mining data script file, that's right here. So that's what we want to upload into our copy of RStudio. And here it is. So it will unpack into its folder right here. Now, when you look at this, what you'll find is a script file and then a couple other folders. So let's just first look at what's in here. If you look within text documents, you'll see a folder called Federalist Papers, and then we're going into a rabbit hole of different subfolders. There's one called Corpus, which is the folder that contains all of the Federalist Papers. So from disputed 49, they're not organized in alphanumeric order, down to Madison 58. So you click on these, and it's just the text, the full text of the actual Federalist Papers, from beginning with the title. So of course this is the famous Federalist 10, down to the end where their name, Publius, is signed. So that is one set of documents that you have here. Now I'm going to click back into this folder right here, and then you can see within this other documents folder, just for fun, a copy of Shakespeare's plays organized into genre. So it's interesting. You can apply this technique to of looking at patterns of function words within Shakespeare's plays, and it's interesting, I think, that you find that between the historical, the comedies, the dramas, for instance, you see, or the tragedies, you can see differences, clear differences in writing style. So it's just interesting. I mean, this is just another fun example of this. But as well within it, there's a copy of presidential inaugural addresses. Now, you wouldn't expect there to be, given that they're distinctly different authors, a whole lot of similarities, but there are some other techniques of data analysis which you might want to work on and apply to this set of documents, and I'll point out what those are at the end of the video. It's not required. All that you're required to do for this assignment is to put together an analysis of the Federalist Papers. So let's go back to the main folder and let's open up the script file and get started. So the first thing that you're going to have to do is to get the stylo package installed. So the package, you'll need to install it with this line. And installing it can sometimes take a few minutes. So for the purpose of this assignment, I'm not going to show you the sequence of steps or just the sequence of messages and the time elapsed to install the package, but you should be able to install this package, and then when you run the library line, you should see something like this little message here in red. Now, you will see a warning message, could not connect to display :0. You don't need to worry about that. What that means is that actually the package itself also has its own user interface for people who don't even want to do any R coding at all. They can just click buttons in these menus that come up. However, that does not work on the RStudio server here at GVSU. It would only work if you had a local copy installed on your computer with some additional stuff set up. So we're not going to need to worry about that. Now, the first thing to do is, and this is explained within the notes, so I would suggest right now after you get it installed, just looking through some of the notes down to the assignment questions so you'll have a sense of what we're doing. We have to get our working directory set to the location that the stylo package expects all the documents to be recorded or to be saved. And so to do that, what we need to do is to set our working directory to the directory above the folder that's labeled corpus that contains the full text of the Federalist Papers. So in other words, when we are here with our text documents into the Federalist Papers and then into corpus, we want to have the working directory set to this location of the files pane right here, so that we're looking at a folder that's called corpus that contains the text documents that we want to analyze. So what we will do is set the working directory to the files pane location, and it's going to look something like this. Basically, you'll know that you have the right location set up if you type dir, open and close parentheses, and you see corpus. So this is very easy. So the analysis is very easy, and we saw examples of this in one of the previous videos from the Module 5A. So once we have the working directory set, it's time to do the command that performs an analysis exactly like we've seen in a previous video, the video from 5A about how we do these sorts of analysis. And it's pretty easy. It's just one function within this stylo package, one function called stylo. And what it asks you for is the minimum number of words and the maximum. Now, you want to set those to the same number. If you choose different numbers, what it will do is produce a sort of sensitivity analysis to assess how differently the relationships between the documents appear given the number of words that you use. But if we set this, for instance, and I'm going to copy and paste it so we can look at a few different examples. If we choose, for instance, the 10 most frequent words as the minimum and then the 10 most frequent words as the maximum, it will just do an analysis of the 10 most frequent words. And so again, like we discussed in Module 5A, while there are various ways of doing it, what we are doing is using the stylo package to create an input matrix of distances between the words, and then to use that multidimensional scaling algorithm to plot a two-dimensional solution that takes those input distances and represents them in a two-dimensional space. So it's the same method, of course, that we used with the analysis of roll call voting, but the input here is word frequencies instead of roll call votes. Now the n-grams, we talked about this. If we're doing n-gram size equals 4, that means we're looking at 4-word phrases. If we choose number 1, then that means that we're just looking at single words. So this stylo function here, once we run it, will produce an analysis of the 10 most frequent words. It will count up all of those words across all the different Federalist papers, create a distance matrix among them, and use that as the input into this MDS procedure and output a two-dimensional picture of the similarity between the different text documents. So it takes a few seconds for it to run, but usually not too long on the server. So I've highlighted it. I'm going to go ahead and run it, and we'll see what happens. So that was pretty quick with only 10 words, not a very complicated analysis for this server, but let's look at what this shows. So there are a lot of different things you can do with this package, many other different options, and you can read about it. There's a link on in this week's Blackboard folder. If you want to read about some of the other options, you can perform an analysis where you actually sample from the text rather than use the entire text. So it's telling us we're not sampling anything, we're using the entire text. We're taking the input text and slicing it into tokens, meaning we're finding all of those n-grams, turning words into features. It's telling us we have 85 different samples or 85 different text documents. That makes sense. The corpus consists of 191,376 tokens now, so that's the total number of different words used across the Federalist Papers. So what it's doing here then is calculating as a input distance metric. It's using these delta distances like we talked about in one of the previous videos, the video for week 5A. These are the videos where those frequencies are converted into z-scores, and this is useful when the documents have a lot of different sizes to them, right? If one document is shorter than the other. This isn't so much of an issue with the Federalist Papers. They're all roughly the same size. So we'll look at in just a few minutes what this analysis is, or how it appears when we do Manhattan distances, for instance. We looked at that distance metric as well. So it tells us that there's some additional files here put within our working directory, and we can see that right here. So first of all, before we get to the actual picture, let me just click on some of this stuff to show you. So here's the word list. So these are all the different words used within the text file. And so our analysis just took 5, 6, 7, 8, 9, 10. It looks like, is that 10 words? The first 10 words, to use those as the frequencies. There's some others here. These are going to be harder to look at because we can't, it's a big matrix. And so I'm just pulling it up here as a text file. But this is the input matrix showing us for different words those z-scores. So we'll come back to this, or we can come back to this in the discussion board for this week if anyone wants to get further into this subject. But for right now then, let's there's something here that shows just a configuration file. You can ignore this, and then there's just this additional CSV file. You can open this up if you want to in RStudio and take a look at it. It's useful if we wanted to plot a network diagram that shows how closely the papers are related to each other, but we're not getting into that. But if anyone is interested in doing this, plotting a network diagram that shows the relationship between the different texts, which ones are closer to others, let me know and we'll go over it on the discussion board. The main point of all this, though, is right now sitting in the plots window. So let's click plots and zoom in and take a look. So here Stylo presents this graphic for us automatically and uses as input the names of the documents for plotting the points. So it's interesting. It's fun that it does all this for us automatically, but you can see here, right, clearly, even based on just the first 10 most frequent words that we have highlighted over here, John Jay had a distinctly different writing style from Hamilton and Madison. And you can see there's still this cluster of Hamilton's writings here, Hamilton-Madison's here, and the disputed text and Madison here within the middle. So when you look at these, remember, we're not so much interested in, the precise numeric scores, say a -1 versus a -0.5. These are just numeric placeholders for the algorithm to plot the differences. What you're interested in looking at are directions and clusters. So clusters and directions. Is there some interesting direction of one particular cluster of text that gives you, in this case, some sort of clue to who the author might be? Now, this is just the 10 most frequent words. We can do this with more frequent words than this, but what I would first like to show you is what the options look like for graphing that figure with an input distance of Manhattan distances rather than the delta distances. And so the help file is here. And I forgot, actually, this help file does not help us to do that. So I think we need to go back to the notes. This is that analysis file here. So I'm not sure, maybe I didn't include it within the notes. But if we look at okay, it is distance.measure equals Manhattan. This should give us the Manhattan distances. Yep, it did. So you can see that it doesn't guarantee that the orientation of the document is going to be the same. And you can see these X and Y axes scales have changed. But of course, again, that's based on the input metric. But you can see the arrangement of the points is basically the same. I mean, if we were to rotate this figure, I think, we would see that it looks pretty identical to what we observed with the delta distances, the z-score based distances. Just for comparison, I think we can go back. So this is our plot with the Manhattan distances, and this is the plot with the others. So, everything is sort of squished together here, but you can see it's pretty similar. So, this is one of the results, of course. There are going to be some differences. I mean, I think you might have noticed the Hamilton and Madison documents are clustered closer together with the delta distances than they are with the Manhattan distances. So this method of analysis is definitely sensitive to the input distance metric. But in my experience, generally speaking, the conclusions that you draw in broad terms usually are not going to change based on the input metric. So what we will do here is, or what you're given the assignment to do, is to pick out a particular number of words to analyze and then to study in terms of n-gram size. So you could choose any n-gram you want and any number of word frequencies and write about what you observe. So that is right here. You're asked to try out 4 different combinations. Just try out some stuff that's interesting to you, see what you find, and then out of the 4 that you tried, what do you think, which method do you think best distinguishes the underlying authorship? Okay, so when you do that, sometimes this package will give you some trouble when we're putting it into our Markdown. So I'm going to try that right now. And I'm going to delete this part here, and then we'll create a new R chunk. I'm going to save this document, the R Markdown document. I'm going to save it within the document that will be, or within the folder that will be our working directory. Part B module, or let's see, module 5B part 2 right here. We are going to have to first call up the stylo package. It's already installed, and then let's try just running one line here and see what happens. Now, it's possible that what you're going to have to do is just run the different plots and then insert those as graphics, copy paste them into your Word document for 5B Part 1. Regardless, you'll have to combine the two different parts to submit your work. You could try creating two different Word documents, or you could perhaps just go with copy pasting your document. Copy pasting the code that you used here and then the actual graphic into your Word document. But let's see what happens when we try this. So I'm going to net it to a PDF. So yeah, so this worked. This is okay. If you did this in a Word document, it should work as well. The hard part might be getting the figure dimensions set. We tried this, fig.height equals 7, fig.width equals 7, or 8. We can try this again. Of course, again, you'll want to net it to a Word document. So yeah, so there we go. So that looks good. So this should work for your Word document. If you have any trouble, it's okay. Then just copy paste the image files and your code into your Word document for 5B Part 1. Okay, so good luck. If you have any questions, let me know.